So we're going to be talking a little finance today. We're going to be doing credit card and consumer loans. So credit cards, most people know what they are. Like the whole idea is that you get some credit, and like if you don't pay it back within the month, then like you have to pay some charge on there. So it offers consumers money in advance. That's your credit in exchange for potentially a finance charge if you're not paying it back on time. So when the balance is not paid back in full by the due date, the user is going to accrue a finance charge, which is often a percentage of the average daily balance. The average daily balance is just calculated as follows: is you just take like the balance on each day of the month, or whatever the pay period is, and then just take the sum of all of those amounts on each day, and then just divide that by the total number of days in the billing period. So again, it's the sum of the total amounts owed on each day of the month. If like the first day you owe $10, the second day you owe $20, the third day you owe $30, and so on, you would add all those up and then divide by the number of days in that billing period, usually 30 or 31, right? So let's suppose that an unpaid bill for $500 had a due date of January 5th, and a purchase of $50 was made on January 10th. Payment of $150 was made on January 20th. A payment of $20 was made on January 22nd. And the interest on the average daily balance is just 2% each month. Find the finance charge on the February 5th bill. So let's compute the average daily balance using this table. So you don't have to do this with the table. There's like multiple ways that you could do it. This is just one way that you can go ahead computing this. The book does this, and I think it's visually nice and kind of helps you organize your thoughts a little bit. So we're going to go with this. So we're just going to list the dates over here, and then anytime that the balance changes, we're going to sort of update the table, right? So from January 5th through 9, the balance is just going to be $500. So the unpaid balance is just $500. And then from the 5th to the 9th, 5, 6, 7, 8, 9, that's 5 days. So we're going to do 500 times 5, which is 2,500 total dollars. Okay. So effectively, like what we're doing in this column of the table is we're adding up the balance for the first 5 days. So for the first 5 days from January 5 through 9, the daily balance is going to be 500. That's not changing, and we add that up 5 times. 500 times 5, that's what we're tallying here. And then we're going to do this like every time that like this balance changes, and then add all those up to get like our total column at the bottom. Okay, so we don't really have to put anything over here because we haven't like made any payments or purchases. I guess right here, like it's going to be like 5 days until the balance changes, because on January 10th, we make a purchase. So a purchase of $50 was made on January 10th. Okay, so purchase of $50 is going to be made. And then the new unpaid balance is going to be $550. Because if they made a purchase of $50, then that means that the balance is going to go up by $50. Okay, well, how many days until the balance changes? Well, the next time that something happens is on January 20th when we make a payment. January 20th is 10 days later, 10 through 19, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yep, that's 10. And so the balance is going to remain at 550 for a total of 10 days. 550 times 10 is $5,500. All right, and then just continuing, on the 20th, we make a payment of 150. So we make a payment of 150. To denote that this is a payment, so because it's a payment to the credit card, the balance is going to go down. So we're going to write negative 150 because the payment will bring the balance down. The next time something happens is going to be January 22nd. So that's going to be 2 days later. What's the balance going to be for this 2-day period? Well, it starts at 550. We bring it down by 150, takes it down to 400. And then 400 times 2 is just 800. All right, last thing that happens is on January 22nd. And then a payment of $20 was made. So they pay $20, so the balance is going to go up by $20. All right, and then how many days from January 22nd to February 4th? Well, January 22nd, so I'll just kind of count this in my head, or out loud, I guess. 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. That's 10. And then 1, 2, 3, 4 till the 4th, so that would be 14 days. Let's double check that this this adds up to the correct number. So let's see. 5 plus 10 is 15, 17, and then 17 plus 14 is 31. And so that's good. That tells us, well, there should be 31 days. So if this column did not add up to 31, then I would know that I did something wrong because January has 31 days in it. So January 5th to February 5th, that time frame will be a 31-day time period. Okay, let's fill out this last part of the column. So the balance goes up by $20, so $420, and then stays there for 14 days. And let me type into calculator. 420 times 14 is 5,880. $5,880. Let's make our total column. This is going to help out here. So the total column, I'm just going to add all of these things up. Okay, so we do 5,880. That's stored in my calculator here. So let's just do that. Plus 800, plus 5,500, plus 2,500. And we get a total of 14,680. Okay. Oops. Oh, I thought this is okay. Sorry, I misremembered how my slides were organized, but it's fine. Okay, so now to compute the average daily balance, this is just going to be that total, 14,680 divided by 31 days. Which is equal to, let's just say roughly equal to $473.55. Okay. So yeah, that's the average daily balance, and this number seems about right because for like 15 days the balance was like hovering between 500 and 550. And then for the next 16 days, the balance was hovering between 400 and 420. 473 is like somewhere in the middle of all that. So that kind of checks out. All right. All right. Now, how to compute the finance charge. So the finance charge is just going to be usually just a percentage of the average daily balance. So this is the average daily balance. And then so this is telling us that the interest on the average daily balance is just 2% each month. So all we have to do is figure out the average daily balance, that's this, and then just take 2% of it. So multiply this by 2%, or multiplying by 0.02. And that would be just $9.47. Okay, so it's just going to be $9.47. Cool. Yeah. So that's it. That's the finance charge. These examples can be like a little bit long, and a lot of details kind of going on with them. There's more examples in the book. This is one of those sections I kind of recommend you kind of work through in the book a little bit. The book's a good resource for this section in particular, I think. So once you kind of watch this video and work through like these examples here, maybe also work through the examples in the book just to make sure everything's kind of settling right in your head. Okay, APR and APY are like basically the same thing. Okay. So APR is the effective annual interest rate on which credit payments are based. APY, annual percent yield, is like similar, but not exactly the same thing. It takes compounding interest into account. So like APR, or maybe I'll say APY. APY, if you're like not making any payments on your loans, the APY, you can think of it as just like that's how much money, how much interest would actually accrue on it. So like if you have like a 12% interest rate, but it's compounded monthly. If you remember from the previous video, you're not exactly going to make 12% interest in that year. You're going to actually earn a little bit more than 12% interest. And how much interest you would actually make would be called the APY. The APR would not actually be taking into account the compounding interest. The book actually says that these two things are the same, and effectively you can think of them as the same, but through at least one source that I've kind of read online, this is like the main difference between them. So not too important, but I'll just kind of make note of it here. But anyway, let's kind of do like a example with APR. So let's say that Jimmy is borrowing a $3,000 loan from a bank with 12% simple interest rate that he plans to, sorry, that's a typo, let's say, pay back over 3 monthly payments. So let's kind of go through some calculations here. So first off, how much simple interest does Jimmy owe? Well, it's a $3,000 loan, 12% simple interest rate, is paying back over 3 months. So you do 12% of 3,000, and then because you're doing 3 monthly payments, this 12% is like an annual interest rate. And so if you're doing it over 3 months, which is like 3/12 of the total year, or just 1/4, then you do 3,000 times 12% times 1/4 of the year. And that gives you $90. That's how much interest is owed. Okay, cool. So if he is going to owe a total of $90 over those 3 months, then you would guess that, well, he's going to have to pay back a total of $3,090. And if he's going to split that equally over 3 months, then that would be $1,030 that he would be making each month. Okay, and so that would be a perfectly fine first guess for the monthly payments. If he's going, so what we're kind of build up to is like, If you want the payments to be equal payments, then this guess is actually going to not quite work out. This is going to be like a little bit of an overestimate, and we'll see why. So in the first month, so remember this is like a 12% interest rate, so if I know it says like simple interest rate over here, but at the same time, like this is going to be compounding each month. And so we're going to apply 1% interest over each of those 12 months for a total of 12% interest over the course of the year. And so the first month, we're going to apply 1% interest on how much money is there, which is $3,000, and then 1% interest on $3,000 total is just $30. Okay, so what's the balance before the payment? The balance before the payment is just $3,030 because it just goes up by that much. And then the monthly payment is $1,030, and so the balance after the payment is going to be $2,000. All right, well, what about the second month? 1% interest again. Here on $2,000, 1% is going to be $20. So the balance is going to go up to $2,000 plus 20. And then he's going to make the same monthly payment of $1,030. So 2020 minus 1030 is equal to 990. That's how much he owes after the second month, after the second payment. And so on the third month, before he makes the payment, 1% interest on the $990 is going to be $9.90. And so just before he makes that payment, before he goes to make that payment, the balance is just $999.90. And he's getting ready to write a $1,030 check, which would be $30.10 too much, right? So in this very basic example, doing this monthly payment thing, this ended up being like a slight overestimate if he was going to do equal payments over all of the months. But you know, the kind of the point of all of this is, it's that like you're not, how do I say? It kind of the point is like that, like the interest that's like being made over like the course of like these 3 months is not like exactly equal to the $90, right? Because you know, if he was paying $1,030 every month, then he would be spending a total of $3,090, but he actually has to spend a little bit less than $1,030 every month. And so the total interest that he's going to be owing is going to be a little bit less than $90. It's going to be like about $60, based off of the fact that we were like $30, like about to like overpay by $30 at the end of this. Anyway, so let's kind of do a slight shift from that. So like, here's a formula. So this formula right here approximates the APR for a simple interest rate loan. So N is going to be the number of payments that you're going to be doing this in, and then R is going to be the simple interest rate. Then the APR is roughly going to be equal to 2 times N times R divided by N plus 1. Okay, so going back to that previous example, Jimmy borrows a $3,000 loan from a bank with 12% simple interest rate. He's paying back over 3 monthly payments. What is the APR actually? So we can, so we can take this formula. Can I just copy that? See if that works. Sweet. So 2 times N times R. So what is N? N is the number of payments. So he's making this in 3 monthly payments. R is the simple interest rate. So that's just 0.12, 12%. And then this is divided by N plus 1. So 3 plus 1, which is just 4. So this is 2 times 3, which is 6, times 0.12 over 4. what does calculator say that is equal to? 6 times 0.12 over 4 equals 0.18. So the APR is roughly 0.18 or 18%. So this is saying that like how much interest he would actually expect to make over the course of a year would be 18%, not 12%. But again, he's paying it over 3 monthly payments, so like, you know, all of these things are like it's kind of confusing, honestly, if you ask me, like what exactly like APR sort of represents in the grand scheme of things, or with like specific examples. But hopefully this is like kind of clicking, and the more that you kind of work with this stuff, like the more intuitive it sort of becomes. And so anyway, so let's just kind of do some more examples just to sort of let things settle a little bit more. So here, Jackie is buying a used car for $4,000. He pays 20% down, and he agrees to repay the balance in 6 equal monthly payments. The finance charge on the balance is just going to be 9% in simple interest. So we're going to do two things. We want to find the finance charge, and we want to estimate the APR. Okay, so let's compute the finance charge. So for like the rest of like these slides are just kind of like we're going to be like doing like a lot of formulas, and so I'm not going to be writing as much. I'm just going to be sort of doing pauses on the slides. Hopefully that'll make things go a little smoother. So let's find the finance charge. So first thing that happens is like, so he wants to put 20% down on this $40,000. And then he's going to repay the balance in 6 equal monthly payments. And these equal monthly payments aren't going to include the down payment. So we got to get rid of the down payment first. So the down payment, 20% of $4,000 is just going to be $800. So we get rid of that from the amount owed. So $4,000 minus the $800 down. Jackie owes $3,200 at this point. Okay, so what's the finance charge? The finance charge on the balance is just 9% simple interest. So we take the amount owed, and then we compute 9% of that. That is equal to $288. Okay. And so now we're done with the first part. We've calculated the finance charge. So we found the amount owed by taking away the down payment and then just computing 9% of that. All right, and then to estimate the APR, we can just use that nice handy formula again, 2 times n times r over n plus 1. So what is n? N is the number of payments, and he's repaying the balance in 6 equal monthly payments, so n is 6, and then the finance charge is 9% simple interest, so r is going to be 0.09 or 9%. So we plug all this stuff in. 2 times 6 times 0.09 over 7 is equal to 0.1543-ish, which we're rounding here, and this is roughly, and so this is equivalent to 15.43%. All right, cool. All right, monthly payment formula. So going back to like that other like kind of weird, confusing example where we were like paying like $1,030 each month. If you didn't want to have like an overpayment on that last month, or if you wanted to just pay the same thing every single month and then have your every single month be like the same equal payment, and it just works out really clean, you could basically just use this formula. So the payment is going to be equal to A times R over N divided by 1 minus, parentheses, 1 plus R over N to the negative N times T. So what is everything here? So A is going to be the loan amount. R is going to be the annual interest rate. N is going to be the number of payments per year. And T is going to be the number of years that you're going to be paying it for. Okay, let's see how to implement this. So let's say that Sean is taking out a loan. Loan is $2,000. Oops, I changed Sean's name over here. So he's taking out a loan for $2,000 that he's going to repay over 4 months, over 4 years in monthly payments. Annual interest rate is just going to be 5%. Let's calculate Sean's monthly payments. Okay, so the formula again is that the monthly payments are going to be equal to A times like this giant fraction thing. And so what are all of the variables here going to be? So A is going to be the amount owed, which is just $2,000. There's no like down payment. There's no like interest that's being made here. So like computing this amount here in this case is like pretty simple. It's just kind of told to us. R is the annual interest rate. That's just 5% or 0.05. N. So N is, let me go back to the formula. So N is the number of payments per year. So like this says monthly payment formula, but this applies to like if you wanted to make like semi-annual payments or quarterly payments or something like that. N is just going to be the number of payments per year. So if it's a monthly, you're using it as a monthly payment formula, N is always going to be 12. So in these examples, N is pretty much like always going to be 12 because we're usually going to be doing monthly payments. That's just like the most common way to do it. Okay, what else? We have to know T. T is the number of years. Yeah, so T is like the number of years that you're going to be doing this for. So N is like the number of payments per year, and then T is the number of years. So T is going to be 4 because he's repaying this over 4 years. Okay. Now, what if you were to do this over like 2.5 years or something like that? Well, this could be like just 2.5, like a decimal, like it doesn't really matter. Okay, so you plug all these values in, and then you get this. So 2,000 times 0.05 over 12 divided by 1 minus 1 plus 0.05 over 12 to the negative 12 times 4. So now in my calculator, I don't type in 12 times 4. I'll usually, and it's good to have like parentheses around this when you do this, but I'll usually just write parentheses like negative 48 or something like that. Not too important, but anyway, so you type this into your calculator. It gives you a monthly payment of $46.06. Okay, let's do another example. This one's going to be with student loans. We really just have like 2 more examples, and then we'll be done. So here, Jeremy is taking out a subsidized student loan for $10,000 with an annual interest rate of 6.5%. Let's say that Jeremy is going to graduate in 3 years, and he's going to repay the loan in monthly payments over 6 years. Let's calculate the monthly payments. All right, so these loans are subsidized, which means that he's not going to be making any interest over the 3 years that he's in school. So, so we have our monthly payment formula, and if we're going to list out all of the things that we need to plug into this, the amount A is just going to be $10,000 because this is a subsidized loan. Subsidized loans, if they're not like accruing any interest by the time that he starts making payments on them, this is just going to stay at a flat $10,000. Okay, so N is still going to be 12 again because he's making 12 monthly payments a year, and he's going to pay this off over a total of 6 years. So T is 6, and then his interest rate is 6.5%. So 0.065 would be our interest rate R. We plug all of this stuff into this formula, and what do we get? We get 10,000 times 0.065 over 12 divided by 1 minus 1 plus 0.065 over 12 to the negative, and this would be 72 up here. Calculator tells me that this is $168.10. So this would be our monthly payment. By the way, if you're ever not super confident in your answer, it's good to kind of do a reality check with this. So what's a good way to kind of just do a reality check, just make sure that this is making sense? So if he's paying this back over 6 years, so he's paying for 72 months. 6 years times 12 months is 72 months total. And he's paying $168.10 per month over a time period of 72 months. If I do 168.10 times 72, what is this equal to? This is equal to $12,103.20. Okay. So does this make sense? So he started with a $10,000 loan, and so he should pay at least $10,000, and he's making like 6.5% interest, and this is like accruing over a span of like 6 years. So what's like 6% of 10,000? It's 600, and then 600 over times 6 is 3,600. So if you were to add I should have done like 6.5%, but you get the idea. So like this number should be somewhere between 10,000 and like 13,000 is what I'm saying basically. Because if you were to add like that interest that he would, pay if he like wasn't paying anything over those years, I'm just doing a basic computation using like simple interest, which is technically incorrect, but like I'm just doing a reality check just to make sure that these numbers are kind of checking out. Anyway, so moving on. Let's do unsubsidized loans. So let's say that Leslie is taking out an unsubsidized student loan for $8,000 with an annual interest rate of 4%. Leslie's going to graduate in 4 years, and she's going to repay the loan in monthly payments over 5 years. Let's calculate the monthly payments. So with unsubsidized loans, the main difference is that these are actually going to be accruing interest while in school. So the amount that she's going to need to start paying off once she gets out of school is going to be higher. So the amount A in particular, when we're trying to like list everything out, the A is not going to be equal to 8,000 in this case. It's going to be larger than 8,000. How much larger than 8,000? Well, we need to figure out, how much interest is she going to accrue over those 4 years, and then just add that to the 8,000. So what's the interest? Well, the interest, so she's making 4% interest over 4 years. So we're using like the simple interest formula here. So $8,000 times 4% over a span of 4 years. Calculator says this is equal to $1,280. So she's going to make this much interest. This is in simple interest. If this is going to be like in compound interest, then you would have to do that slightly differently, but we'll just assume simple interest for now. Hence, the amount owed is now going to be A equals 8,000 plus that interest. 8,000 plus 1,280 is equal to 9,280. So this is going to be our amount A. So now going to our formula for our monthly payments, we now know what A is. A is going to be 9,280, and then everything else we're just going to plug in really similar to how we did it before. So R is going to be just 4%. N is going to be 12 because we're making monthly payments. T is going to be equal to 5 because she's paying this off in 5 years. The most like common mistake that, or a very common mistake that could get made here is like mixing up like the 4 and the 5 when you're doing this. The 4 years comes into a play when you're calculating the interest. The 5 years is like she's making payments over 5 years, and so that's going to be the one that shows up in this formula here. Okay, so we plug these and our value of A into our formula. We get the following, and this is equal to $170.91. Okay, so that's a lot of number crunching with this, a lot of formulas to be sure. Hopefully things kind of made sense. Um, I kind of think that like this is one of those sections where it makes more sense when you kind of work out the examples yourself. And I know I didn't really give you a lot of opportunities to kind of do that in this video, but I do recommend kind of getting as much practice with these types of problems as you can. So maybe if the WebAssign problems are not really enough, I would actually like this might be like one of those sections where I would recommend kind of looking through the book examples and maybe even like picking out like a few examples from like the textbooks, like practice exercises at the end of that section, just to get like a little bit more familiarity with it if you feel like you need that or would benefit from that. Yeah, I think that's all I have to say for that. So yeah, thanks for listening. I hope this helped, and see you in the next one.